As the second topic of today, let's discuss about Mohr circle for plane strain problem. So until now, we considered plane stress problem and Mohr circle for stress and stress transformation. Now we'll consider special case plane strain problem and we'll consider Mohr circle for strain and the transformation of strain. So let's first define what plane strain problem is. First, we already defined plane stress problem. Plane stress problem is a problem such that sigma z and tau xz and tau zy equals to be 0, so that you can effectively consider only in-plane stress. Plane strain problem has slightly different meaning. The strain along z direction is 0 and shear strain along xz and yz component is 0. Okay, of course, due to the Poisson ratio effect, sigma z is usually non-zero, and which is the different case for the plane stress problem. Even though the sigma z is 0, due to the Poisson ratio, epsilon z is usually non-zero. Okay, so this is the difference between plane stress and plane strain. And today we'll focus on this special case: epsilon z equals 0, gamma x z equals 0, and gamma yz equals to be 0. And of course, I can go through the same geometric consideration I did for general stress state in 3D. However, I will just refer all those discussions to the textbook. So if you go to the textbook, they have done the geometric analysis. If you are interested in, please read by yourself. And it is shown that we can obtain the relationship between epsilon x prime, epsilon y prime, and epsilon gamma x prime y prime, and the epsilon x, epsilon y, and gamma xy. Okay, so we can derive this relationship in a quite similar manner where we obtained the relationship between stress value. And if you compare the equation for strain with the equation for stress, we found like a huge analogy. So if you see epsilon x prime expression, it's in the similar location, analogous location with the sigma x prime. If you look at epsilon y prime, it's located in a analogous location with the sigma y prime. If you look at gamma x prime y prime, found here and there and there, I'll just make circle here. You're gonna make circle here, there, and there. If you compare tau x prime y prime and gamma x prime y prime over 2, then they are located in the same position in this equation set. Okay, so what you can see here is, because Mohr circle is a simple graphical way of memorizing the equation, you can use the Mohr circle concept for this strain equation, because except this factor over 2, it looks almost the same as the stress expression, and the location of cosine and sine, and the the positive and minus in terms of the each terms are equal to each other. So you can utilize the Mohr circle concept by replacing sigma x prime with epsilon x prime, sigma y prime with epsilon y prime, tau x prime y prime with gamma x prime y prime divided by 2. Then you can simply utilize the Mohr circle concept. And of course, before moving on, let me just make one comment. This gamma xy is called engineering strain, and you're gonna learn this in later lecture. If you consider gamma xy over 2, and it is typically written as epsilon xy, it is called tensorial strain. You can learn about the concept of engineering strain and tensorial strain and the concept of tensor in the solid mechanics 2 class. I think it's like a foundation of stress analysis. I don't know why professors named the lecture in this way, but I consider that as undergraduate solid mechanics 2 class, and you're gonna learn about more mathematical details in that class. Okay, so as I told you, due to the analogy, we can simply use a Mohr circle for plane strain problem if you are careful about gamma xy over 2 factor. So back in plane stress problem, when building up the Mohr circle, we considered the sigma average to locate the center position. We consider radius of the Mohr circle, to find the radius, and and it's given as this in plane strain problem. The average is given as epsilon x plus epsilon y divided by 2, and the radius of the strain Mohr circle is given as simply replacing sigma x with epsilon x, sigma y with epsilon y, and tau xy with gamma xy over 2. Then you can obtain the radius for Mohr circle. And in drawing Mohr circle, your horizontal axis and horizontal reading will be epsilon. Your vertical reading and vertical axis will be gamma over 2. So please be careful, and other than that, everything is the same. So when you first construct the Mohr circle, you have to locate x position and y position. X point is composed of epsilon x and minus gamma xy over 2. And y position is composed of epsilon y along horizontal reading and gamma xy over 2 along the vertical reading. Okay, and the center is given as epsilon average and 0 position. And the maximum shear strain is given as this point. The maximum reading of r gamma over 2 is the top of this circle, which is r. So you can obtain the maximum shearing strain as 2 times radius, and 2 times radius is given as this. Okay, this is how you construct and utilize the Mohr circle for plane strain problem. So let's solve one example problem. So in this example problem, we'll consider one specimen with 10 millimeter along the horizontal direction and 10 millimeter along the vertical direction. And suppose that this is just simple two-dimensional film, and after the deformation, along the vertical direction it has the same length. Along the horizontal direction it has the displacement of 4 micrometer, and along this shearing direction the angle changes from pi over 2 to pi over 2 plus 0.4 times 10 to the negative 3 radian. Then, and based on this strain state, and based on this geometry, the problem asks what is the strain component epsilon x, epsilon y, and gamma xy, and what is the principal strain and maximum shear strain. Okay, so let's first answer the first question. Let's first consider epsilon x. Epsilon x can be obtained by displacement 4 micrometer divided by original length 10 millimeter, and micrometer is 10 to the negative 6 meter, and 4 meter can be written as 0.004 millimeter. And if you do this calculation, it's of course strain is dimensionless number, as I told you in the first lecture of this ME231. It's given as 4 times 10 to the negative 4th power, and of course epsilon y will be 0 because there is no change in length. Regarding the gamma xy, gamma xy is defined as pi over 2 minus gamma xy. Typically, it is given as pi over 2 minus gamma xy, and this must be same as pi over 2 plus 0.4 10 to the negative 3rd radian, and gamma xy is given as minus 4 times 10 to the negative 4, of course in dimensionless number. Okay, so after identifying epsilon x, epsilon y 0, and gamma xy, which is negative 4 times 10 to the negative 4, then we can construct the Mohr circle. To construct the Mohr circle, we have to obtain the average normal strain, which is 4 and 0, 2 times 10 to the negative 4, and the radius by plugging in epsilon x, epsilon y, and gamma xy value, we end up having 4 divided by 2, 2 to the square, 2 to the second power, and gamma xy is given as negative 4. It's 2 to the power, so 4 plus 4 is 8. So square root of 8 is 2 times square root of 2 and multiplied by a factor of negative 10 to the negative 4. So it gives us radius, and the location of x is given as epsilon x and minus gamma xy divided by 2. Please be careful about this factor over 2. Other than that, this is similar to plane stress problem. And regarding the y position, epsilon y and plus gamma xy divided by 2. So which defines x as 4 and 2, y as 0 and negative 2, multiplied by this 10 to the negative 4th power. So if you specify the x position, y position. It's given as x here and y here, and the origin is here. And after completing Mohr circle, you can find the plane strain, no, principal strain value and the maximum shear strain. Okay, so maximum shear strain would occur here and here by rotating this angle by 2 theta s, and the principal stress would occur by rotating the axis on the Mohr circle by 2 theta p. Okay, and if you look at the position of this 4 and 2 and the location of E epsilon, which is 2 times 10 to the negative 4, you can find that this is negative 45 degree, this is 45 degree. Okay, so after recognizing that theta s is 22.5 degree and theta p is negative 22.5 degree, you can locate the principal axis and the principal strain, and of course the axis for maximum shear strain. So what is the principal axis and principal strain? So as I told you, if you rotate this by clockwise 22.5 degree, yeah, x prime, y prime will give you the principal strain, principal axis, and the normal strain along x prime and y prime will be principal strain. The epsilon x prime is given as epsilon average plus radius of the Mohr circle, and the another principal strain is epsilon average minus radius of the Mohr circle, which is this. So if you plug in numbers, average plus r, average minus r, it gives you these numbers. And at this coordinate system x prime, y prime, of course it's principal axis. The principal the shear strain along that x prime, y prime, the coordinate system is 0. And another question, what is the maximum shear? After rotating your axis by 22.5 degree in counterclockwise, and let's call that as x double prime and y double prime coordinate system, then similar to Mohr circle for stress problem, epsilon x double prime and epsilon y double prime is same as epsilon average, which is 2 times 10 to the negative 4. And regarding the maximum shear strain, gamma x double prime y double prime divided 2 equals to be radius of the Mohr circle, as I told you here. Okay, and if you multiply 2 there, you can obtain the value for maximum shear strain. Okay, so that's the application of Mohr circle for strain. Okay, however, even though I told you how to convert the strain value in other coordinate system, I didn't tell you how to measure the strain itself. I just specified that we somehow figured out these values, and in the next lecture I will tell you how one can obtain the strain values at given position. Okay, so that will be the first topic of next lecture. But today let's stop here, and let's get familiar with the Mohr circle for plane strain problem first. Okay, so to summarize, today we covered 2 topics. The first topic we covered was thin walled pressure vessel, which can utilize all the concepts we learned in previous lecture. And as a second topic, we learn about Mohr circle for plane strain problem and the expansion of this plane strain problem, and further discussion will be given in next lecture regarding stress and strain transformation.